Hello dear students, welcome back to online classes of Vivekananda PU College. So we were discussing about the chapter thermal properties of matter. So in this session we will be solving some problems which is related to the concept of coefficient of linear expansion. So I have written 3 problems here. We will be solving one by one. Hope you have a calculator, pen and paper with you, book. Okay. As I solve these problems, you have to solve along with me. First you write this first problem. Write down the first problem. How much a bar of aluminium 100 centimeter long expand when heated from 20 degrees Celsius to 100 degrees Celsius? Given the coefficient of linear expansion of aluminium is 25 into 10 to the power minus 6 per Kelvin. You can download this video and pause the video for writing these things or write it fast. Now, how much a bar of aluminium 100 centimeter long expand when heated from 20 degrees Celsius to 100 degrees Celsius? Given the coefficient of linear expansion of aluminium is 25 into 10 to the power minus 6 per Kelvin. Okay. See, how much a bar of aluminium? So there is a bar, which bar? Bar of aluminium, whose length is given as 100 centimeter. So the length is 100 centimeter. 100 centimeter. When long expand when heated from 20 degrees Celsius to 100 degrees Celsius. So what have they done? They have supplied heat energy to this bar of aluminium. Temperature has increased from 20 degrees Celsius to 100 degrees Celsius. So when the temperature increases, it expands. So this bar expands like this. Expands like this, right? You have to calculate how much a bar of aluminium expands. So this length, increase in length, you have to calculate. Given coefficient of linear expansion of aluminium is 25 into 10 to the power minus 6 per Kelvin. Understood? There is a bar of aluminium, length is given as 100 centimeter. They have supplied heat energy. Initial temperature was 20 degrees Celsius. When heat is supplied, temperature has increased to 100 degrees Celsius and it has expanded. What is the increase in length? And also they have given the value of coefficient of linear expansion of aluminium. Okay. Now, you got the meaning of the problem now. Now, let us list out the values which is given in the problem. See, 100 centimeter long. Long is nothing but length. Length we denote it as L. L is equal to 100 centimeter. L is 100 centimeter. Okay. Now, temperature has increased from 20 degrees Celsius to 100 degrees Celsius. This is the initial temperature. This is final temperature. Temperature is written as capital letter T. I will write initial temperature as T1, which is equal to 20 degrees Celsius. Similarly, final temperature T2 is equal to 100 degree Celsius. Right? And they have given coefficient of linear expansion of aluminium. Coefficient of linear expansion of aluminium is nothing but alpha L. Right? We write it as alpha L. Alpha L is equal to 25 into 10 to the power minus 6 per Kelvin. Right. Now, what you have to calculate? You have to calculate change in length. This is nothing but change in length. So, change in length is written as delta L. What is the value? Okay. First step, read the problem. Second step, imagine the problem. Third step, list out the given values. Fourth step is look at every values which is in the list now. Every value must be in standard form, that is SI units. What is the SI unit of length? SI unit of length is meter, but they have given here in centimeter. 100 centimeter is equal to how many meters? 1 meter, right? 100 centimeter is 1 meter, or you can write it as 100 into 10 to the power minus 2 meter. Centi is 10 to the power minus 2, or 100 centimeter can be written as 1 meter. And temperatures are given in degree Celsius, but SI unit of temperature is Kelvin, right? So you have to convert this value to Kelvin. How to convert? What is the relation between degree Celsius and Kelvin? Tk, temperature in Kelvin scale, is equal to Tc plus 273.15, or just 273 is enough. So Tk is equal to Tc plus 273. This is the relation which connects Tc and Tk. Hope you remember. So what is 20 degree Celsius? 20 degree Celsius is 20 plus 273. 20 plus 273, which is equal to 293 Kelvin. You can check this in your calculator. 293 Kelvin. Similarly, 100 degree Celsius, convert this into Kelvin. 100 plus 273, which is equal to 373 Kelvin. 373 Kelvin, right? Alpha L is given in terms of Kelvin only, so no need to convert that. Now, fifth step, coming to this fifth step. Fifth step is to write the formula. By looking at all the terms given, you can write the formula. Remember the formula. Alpha L is equal to delta L divided by L delta T. This is the formula. What you have to calculate? Delta L. So you have to write the equation for delta L. Delta L illೇ ಇರಲಿ, L delta T ಅನ್ನು ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ತಗೊಂಡು ಹೋದರೆ ಇಲ್ಲಿ ಡಿವೈಡೆಡ್ ಇದ್ದದ್ದು ಇಲ್ಲಿಗೆ ಹೋಗುವಾಗ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಯಿತು. ಸೊ ಡೆಲ್ಟಾ ಎಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆಲ್ಫಾ ಎಲ್ ಇಂಟು ಎಲ್ ಡೆಲ್ಟಾ ಟಿ. ಆಲ್ಫಾ ಎಲ್ ಇಂಟು ಎಲ್ ಡೆಲ್ಟಾ ಟಿ, ರೈಟ್? So this is equal to, substitute the values. Alpha L, what is the value of alpha L? 25 into 10 to the power minus 6 into L. L is 1 into delta T. What is delta T? Change in temperature, right? So change in temperature is difference between two temperatures. See, we have two temperatures here, 293 Kelvin and 373 Kelvin. Right, change in temperature. How to write? Higher value minus lower value. Higher value 373 minus lower value 293. This is how you substitute the values. Alpha L, L, delta T is nothing but change in temperature, difference between the two. While writing, you have to write higher value first minus lower value. Okay. Now, 25 into 10 to the power minus 6 is here, 1 into 373 minus 293, 80. 80. Right? 25 into 80 is 2000, right? 2000 into, right, 10 to the power minus 6. You can keep answer like this, you will get the full marks. But I will write it in meter without 10 to the power and all. So how to write? See, 2000 into 10 to the power minus 6 is here. You can write it as 2000, 10 to the power minus 6 is nothing but micrometer, right? Or shift the decimals. Illi point hakidre 10 to the power minus 5, minus 4, minus 3, right? 2 into 10 to the power minus 5, 4, 3, minus 3 meter. So you can write 10 to the 2 millimeter, because 10 to the power minus 3 is milli, right? Or if you want to write it in meters, ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಹಾಕಿದರೆ 0.2 ಮಿಲಿಮೀಟರ್ ಉಂಟಲ್ಲ, 0.2 ಬರೆದ್ರೆ ಇಂಟು 10 to the power minus 2 ಆಯಿತು, ಸೆಂಟಿಮೀಟರ್ ಆಯಿತು. 0.2 ಸೆಂಟಿಮೀಟರ್ ಅಂತ ಬರಿಬೋದು. ಅಥವಾ 0.02 ಬರೆದ್ರೆ ಇಂಟು 10 to the power minus 1 ಆಯಿತು. or 0.002 ಬರೆದ್ರೆ 10 to the power 0, but that is nothing but 1. So the final answer is 0.002 meters. This is the standard answer. Standard answer. You can copy the things. See, first step is to read and understand the problem. Second step, imagine the problem. Third step, list out the given values. Fourth step, convert everything into SI units. Fifth step, write the formula which is related and substitute, calculate and get the final answer. And there is mark for final answer. You have to write SI unit of final answer. That is very important. Okay, understood? Okay, if you have finished writing these things, write the second problem question. Okay, the second problem is, see, a brass rod 1 meter long when heated through 80 degrees Celsius increases in length by 1.6 millimeter. Calculate the coefficient of linear expansion of brass rod. Write the problem. A brass rod 1 meter long, a brass rod 1 meter long when heated through 80 degrees Celsius, when heated through 80 degrees Celsius, increases in length by 1.6 millimeter. Calculate coefficient of linear expansion of brass rod. We have read the problem. Understand, brass rod is there, the length is 1 meter, it is heated through 80 degrees Celsius and its length has been increased to 1.6 millimeter. Calculate coefficient of linear expansion of brass rod. See, imagine there is a brass rod of length 1 meter. Okay, it is heated through 80 degrees Celsius. What is the meaning? There is a difference. See, in the first problem, initial temperature and final temperature were given. You have calculated change in temperature. 100 minus 20, 80 degrees Celsius was change in temperature, or convert it into Kelvin and minus 80 degrees Celsius is the temperature, change in temperature. But in the second problem here, it is given that when heated through 80 degrees Celsius, this is nothing but change in temperature only. So it is directly given, change in temperature delta T is directly given here as 80 degrees Celsius. Understood? Right? There is a difference. Here in the first problem, initial temperature and final temperature was given. You have, if you want to calculate change in temperature, you have to take the difference between them, right? But in the second problem, they have directly given that when it is heated through 80 degrees Celsius, heated through 80 degrees Celsius ಅಂತಂದ್ರೆ 80 degrees Celsius ನಷ್ಟು increase ಮಾಡಿದ್ದಾರೆ ಅಂತ. So delta T is directly 80 degrees Celsius. So delta T is 80 degrees Celsius. Calculate the coefficient of linear expansion of brass. So when you supply heat energy, this rod will get expand, and if this increase in the length, see, increase in length is given as 1.6 millimeter. 1.6 millimeter. So what you have to calculate? Coefficient of linear expansion. Third step, let us list out the given values. length of the brass rod is given as 1 meter. Okay. Delta T is given. Delta T is equal to 80 degrees Celsius. 80 degrees Celsius. Increase in length, delta L is 1.6 millimeter. 1.6 millimeter is nothing but 10 to the power minus 3, right? Milli is 10 to the power minus 3. Coefficient of linear expansion you have to calculate. Coefficient of linear expansion you have to calculate. We have listed out every values given in the problem. Let us write the formula. Formula is alpha L is equal to delta L divided by L delta T. L delta T, which is equal to, substitute the values. Delta L value 1.6 into 10 to the power minus 3. Minus 3. L value, L is 1 into. Delta T value 80 degrees Celsius. 80 degree Celsius is equal to 1.6 divided by 80 is 0.02. You can check. 1.6 divided by 80 is 0.02 into, here 10 to the power minus 3 is there. 10 to the power minus 3 is there. Or I can write it as, see, illi point hakidre 10 to the power minus 4, illi point hakidre 10 to the power minus 5. 2 into 10 to the power minus 5. What is the unit? What is the unit of alpha L? Alpha L, see, SI unit of alpha L is per Kelvin. See, in this first problem they have given 25 into 10 to the power minus 6 per Kelvin. Why? Why? Because alpha L is delta L divided by L delta T, right? Writing the units, length meter divided by this length meter. SI unit of temperature is Kelvin. So, meter cancels. SI unit of alpha L will become per Kelvin, because this is in denominator, right? Either you have to write per Kelvin like this or per Kelvin like this, right? But here we have substituted the value of delta T as 80, which is in degree Celsius. Degree Celsius. So, you have to write the SI unit of alpha L here in this case as per degree Celsius. You can write per degree Celsius like this or per degree Celsius. Understood? Copy the things. If you have finished writing these things in your book, write the third problem. See, the third problem says that a steel ring of diameter 142 centimeter at 30 degrees Celsius is to be fitted on a wheel of 142.8 centimeter diameter. To what temperature must the ring be heated so that it fits to the wheels? Given alpha D is equal to 1.2 into 10 to the power minus 5 per Kelvin. Write the problem. A steel ring of diameter 142 centimeter at 30 degrees Celsius is to be fitted on a wheel of 142.8 centimeter diameter. To what temperature must the ring be heated so that it fits to the wheels? Given alpha D. See, let us understand the problem. A steel ring of diameter 142 centimeter. There is a steel ring. Like this. Okay. The diameter of steel ring is given as 142 centimeter. The diameter from here to here, diameter is 142 centimeter. It is maintained at 30 degrees Celsius. It is to be fitted on a wheel of 142.8 centimeter diameter. So, you have to fit this steel ring with a wheel. The diameter of the wheel is given as 142.8 centimeter. So, there is a steel ring like this. Diameter of this steel ring is 142 centimeter, right? And it is initially at a temperature of 30 degree Celsius. 30 degree Celsius. What you have to do? You have to fit this steel ring on a wheel. There is a wheel like this. The diameter of this wheel is given as 142.8 centimeters. So, this diameter is 142.8 centimeter, right? What you have to do? ಸಿ ಮನೆಯಲ್ಲಿ ಒಂದೊಂದು ಸಲ ಏನಾಗ್ತದೆ ಅಂತಂದರೆ, ಎರಡು ಪಾತ್ರೆ, ಒಂದು ಪಾತ್ರೆ ಒಳಗೆ ಇನ್ನೊಂದು ಪಾತ್ರೆ ಹಾಕಿಟ್ರೆ ಅದು ಜಾಮ್ ಆಗಿ ಬಿಡ್ತದೆ, ತೆಗಿಲಿಕ್ಕೆ ಬರುವುದಿಲ್ಲ. ಆಗ ನೀವೆಂತ ಮಾಡ್ಬೋದು ಅಂತ ಕೇಳಿದರೆ, ಒಂದು ಹೊರಗಿನ ಪಾತ್ರೆಯನ್ನು ದೊಡ್ಡದು ಮಾಡಬೇಕು ತೆಗಿಬೇಕು ಅಂತಾದರೆ, ಅಥವಾ ಒಳಗಿನ ಪಾತ್ರೆಯನ್ನು ಸಣ್ಣ ಮಾಡಬೇಕು. ಏನು ಮಾಡ್ಬೋದು? ಇದನ್ನು ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಬೇಕು ಅಂತಾದರೆ ಇದಕ್ಕೆ ಹೀಟ್ ಎನರ್ಜಿ ಸಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ, ಹೊರಗಿನ ಪಾತ್ರೆಯನ್ನು ಸ್ವಲ್ಪ ಬಿಸಿ ಮಾಡಿದರೆ ಇದು ಎಕ್ಸ್ಪಾಂಡ್ ಆಗ್ತದೆ, ಜಾರಿಸಿ ತೆಗಿಬೋದು. ಅಥವಾ ಒಳಗಿನ ಪಾತ್ರೆಯನ್ನು ಕೂಲ್ ಮಾಡಬೇಕು, ಸೊ ದ್ಯಾಟ್ ಇಟ್ ಕಾಂಟ್ರಾಕ್ಟ್ಸ್, ಸಣ್ಣದಾಗ್ತದೆ. ಸೊ, ಕಾಂಟ್ರಾಕ್ಟ್ ಆಗಬೇಕು ಅಂತಾದರೆ ಇದನ್ನು ಕೂಲ್ ಮಾಡಬೇಕು. ಸೊ, ಎರಡು ಪಾತ್ರೆ ಜಾಮ್ ಆಗಿದ್ದರೆ ಹೊರಗಿನ ಪಾತ್ರೆಯನ್ನು ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಬೇಕು, ದೊಡ್ಡದು ಮಾಡಬೇಕು, ಅಥವಾ ಒಳಗಿನ ಪಾತ್ರೆಯನ್ನು ಸಣ್ಣದು ಮಾಡಬೇಕು. ಹಾಗೆ ಇಲ್ಲಿ ಒಂದು ಸ್ಟೀಲ್ ರಿಂಗ್ ಕೊಟ್ಟಿದ್ದಾರೆ 142 ಸೆಂಟಿಮೀಟರ್ ಡಯಾಮೀಟರ್ ಇದ್ದು, ಮತ್ತೊಂದು ವೀಲ್ ಉಂಟು 142.8 ಸೆಂಟಿಮೀಟರ್ ಡಯಾಮೀಟರ್ ಇದ್ದು. ನೀವು ಇದನ್ನು ಫಿಟ್ ಮಾಡಬೇಕು ಅಂತಾದರೆ ಇಲ್ಲಿ ನೋಡಿ, ದರ್ ಇಸ್ ಅ ಡಿಫ್ರೆನ್ಸ್ ಆಫ್ 0.8 ಸೆಂಟಿಮೀಟರ್ ಹಿಯರ್, ರೈಟ್? ದರ್ ಇಸ್ ಅ ಡಿಫ್ರೆನ್ಸ್ ಆಫ್ 0.8 ಸೆಂಟಿಮೀಟರ್ ಹಿಯರ್. ಸೊ, ಇದಕ್ಕಿದು ಫಿಟ್ ಆಗಬೇಕು ಅಂತಾದರೆ ಇದನ್ನು ಸ್ವಲ್ಪ ದೊಡ್ಡದು ಮಾಡಬೇಕು, ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಬೇಕು. ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಬೇಕು ಅಂತಾದರೆ ಈ ಸ್ಟೀಲ್ ರಿಂಗಿಗೆ ಹೀಟ್ ಎನರ್ಜಿ ಸಪ್ಲೈ ಮಾಡಬೇಕು, ಇದರ ಟೆಂಪರೇಚರನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು. ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ 30 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಎಷ್ಟು ಹೀಟ್ ಎನರ್ಜಿ, ಎಷ್ಟು ಟೆಂಪರೇಚರ್ಗೆ ನೀವು ಇದನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು ಅಂತ ಕ್ವಶನ್ ಕೇಳಿದ್ದು. ಟು ವಾಟ್ ಟೆಂಪರೇಚರ್ ಮಸ್ಟ್ ದ ರಿಂಗ್ ಬಿ ಹೀಟೆಡ್ so that it fits to the wheel. So, this is the problem. Now, let us list out the values which is given in the problem. Steel ring of diameter 142 centimeter. Diameter is nothing but a length, so I will write it as L only. L is equal to 142 centimeter. 142 centimeter. Which is maintained at temperature of 30 degree Celsius. That is initial temperature. I will write it as T1, 30 degree Celsius. Now, ಸ್ಟೀಲ್ ರಿಂಗ್ ಅನ್ನು ವೀಲಿಗೆ ಫಿಟ್ ಮಾಡಬೇಕು ಅಂತಾದರೆ ಇದನ್ನು ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಬೇಕು. ಇದರ ಡಯಾಮೀಟರ್ ಎಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು? 0.8 ಸೆಂಟಿಮೀಟರ್ನಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು. ಸೊ, ದಿಸ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್. Change in length delta L is equal to 0.8 centimeter. ಇದು ಹೇಗೆ ಬಂದದ್ದು? 142.8 minus 142 which is 0.8 centimeter. Okay. Question is, to what temperature must the ring be heated so that it fits to the wheel? You have to calculate final temperature T2. Okay. Also, they have given the value of alpha D. Alpha D, coefficient of linear expansion, alpha L is equal to 1.2 into 10 to the power minus 5 per Kelvin. 1.2 into 10 to the power minus 5 per Kelvin. Okay. This is the third step. We have listed the values which is given in the problem. Next step, I'll erase this. Next step is convert everything to SI units. See, length is given as 142 centimeter, but SI unit of length is meter. So 142 centimeter is 142 into 10 to the power minus 2 meter. Centi is 10 to the power minus 2. Similarly, we have 0.8 centimeter here. That is nothing but 0.8 into 10 to the power minus 2 meter. Okay. And temperature is 30 degrees Celsius. 30 plus 273, which is equal to 303 Kelvin. 303 Kelvin. Right? Now, you have to calculate final temperature. How? Let us see. The formula is alpha L is equal to delta L divided by L delta T. Delta L divided by L delta T. We have to calculate delta T first. Change in temperature calculate ಮಾಡುವ. Change in temperature ಗೆ equation ಬರಿಬೇಕು ಅಂತಾದರೆ delta T ಅನ್ನು ಇಲ್ಲಿಗೆ ತಗೊಂಡು ಬರಬೇಕು, alpha L ಅನ್ನು ಇಲ್ಲಿಗೆ ತಗೊಂಡು ಹೋಗಬೇಕು. So delta L divided by L, delta T ಇಲ್ಲಿ ಬಂತು, alpha L ಇಲ್ಲಿಗೆ ಹೋಯಿತು. Okay, this is equal to delta L value 0.8 into 10 to the power minus 2 divided by L value 142 into 10 to the power minus 2 into alpha L value 1.2 into 10 to the power minus 5. Right? 10 to the power minus 10 to the power minus 2 cancels. .8 divided by 142 divided by 1.2. What is the value? 0.004694. Right? 0.004694 into 10 to the power minus 5 is here in the denominator. Let us bring this to the numerator. It becomes 10 to the power plus 5, which is equal to plus 5 ಉಂಟು, ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಶಿಫ್ಟ್ ಮಾಡ್ತಾ ಹೋಗುವ. ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಹಾಕಿದರೆ 10 to the power plus 4 plus 3 plus 2 plus 1 0. Right? So answer is 469.4. What is the SI unit? We have substitute the value of alpha L in per Kelvin. So delta T is in Kelvin here. This is not the final answer because this is change in temperature. What they have asked? They have asked final temperature, right? So change in temperature ಸಿಕ್ಕಿದ್ದು ನಮಗೆ. Change in temperature is nothing but difference between two temperatures, right? Final temperature minus initial temperature, or we write it as higher temperature minus lower temperature. In this case, temperature has increased. So final temperature will be higher than the initial temperature. So T2 minus T1. We want the value of T2. T2 is equal to, bring this T1 here, delta T plus T1, which is equal to, delta T is 469.4 plus T1 is 303. So the final temperature T2 is equal to 772.3 Kelvin. 772.3 Kelvin. Or if you want to write the answer in degree Celsius, what will you do? If you have to convert temperature from degree Celsius to Kelvin, you have to add 273. Right? If you want to write the answer from, convert the answer from Kelvin to degree Celsius, you have to subtract 273. So 772.3 minus 273 will be 499.3 degrees Celsius. This is the answer. Understood? I'll explain this once again. See, there is a steel ring of diameter 142 centimeter at 30 degrees Celsius. This steel ring has to be fitted on to a wheel of 142.8 centimeter. ಹೀಗೆ ಇಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ, ಯಾಕೆಂತಂದರೆ ಇದರ ಡಯಾಮೀಟರ್ ಜಾಸ್ತಿ ಉಂಟು ಸ್ಟೀಲ್ ರಿಂಗಿಗಿಂತ. ಸೊ ಹೀಗೆ ಫಿಟ್ ಮಾಡಲಿಕ್ಕೆ ಹೋದರೆ ಲೂಸ್ ಆಗ್ತದೆ. ಸೊ ಫಿಟ್ ಆಗಬೇಕು ಅಂತಾದರೆ ಈ ಸ್ಟೀಲ್ ರಿಂಗನ್ನು ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಿದ್ದಾರೆ ಅವರು. ಫಿಟ್ಟೆಡ್ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಿದ್ದಾರೆ. ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಬೇಕು ಅಂತ ಅದಕ್ಕೆ ಹೀಟ್ ಎನರ್ಜಿ ಸಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್. 30 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದ್ದದ್ದು ಎಷ್ಟು ಟೆಂಪರೇಚರಿಗೆ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಫಿಟ್ ಆಗ್ತದೆ, ಎಕ್ಸ್ಪಾಂಡ್ ಆಗಿ ಫಿಟ್ ಆಗ್ತದೆ ಅಂತ ಕ್ವಶನ್ ಕೇಳಿದ್ದು. ಸೊ 142 ಇದ್ದದ್ದನ್ನು 142.8 ಸೆಂಟಿಮೀಟರ್ನಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು. ಸೊ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಈಸ್ 0.8 ಸೆಂಟಿಮೀಟರ್, ರೈಟ್, 0.8 centimeter. Initial temperature is 30 degree Celsius. Initial length is 142 centimeter. Write everything in SI units. Now formula is alpha L is equal to delta L divided by L delta T. Delta T ಗೆ equation ಬರೆಯೋದು, substitute ಮಾಡೋದು, will get delta T 469.4 Kelvin. We want final temperature. Delta T is change in temperature, which is difference between the two temperatures. So final temperature T2 is delta T plus T1. Substitute, answer is 772.3 Kelvin or minus 273 ಮಾಡಿದ್ರೆ 499.3 degree Celsius. This is the final answer. You may get plenty of problems on this concept like this. Different problems are there. Try to solve those problems. If you get any doubts, you can ask us. And ಹೆದರ್ಲಿಕ್ಕಿಲ್ಲ, ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡುವಾಗ ಈಸಿ ಆಗ್ತದೆ. ನಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಸರಿಯಾಗಿ ಅರ್ಥ ಆದರೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡೋದು ಈಸಿ. ಸೊ ದಿಸ್ ಈಸ್ ಇನಫ್ ಫಾರ್ ಟುಡೇ. ಲೆಟ್ ಅಸ್ ಕಂಟಿನ್ಯೂ the concept in the next session. Thank you.